I do again the intro, right? The full intro. Okay. Cool. So let's get started. Are we recording? I cannot see that in my screen for some reason. And there we go. Okay, everybody. So let's get started. So right now we're in the second part of our series. This one's going to be an interesting one. I actually have demos for you this time. So for those of you that do not know me, my name is Carlos Perez. I'm the TrustedSec research practice lead. I'm in charge of the research team at TrustedSec. I actually work out of Puerto Rico for TrustedSec. I have actually presented in many conferences, including DEF CON, DerbyCon, HackerCon, and several B-sites. I'm very prolific, you might say, in the open source community. I have written many tools. I think a lot of the post-exploitation stuff inside of Metasploit, I have contributed in some way or another. I have DNS Recon. If you use Azure, more than likely you know Posh SSH. I'm a Microsoft MVP for enterprise security and PowerShell. So most of you probably have seen all of this already. At TrustedSec, right now, one of our differentiating factors is our research team. The research is part out of the Advanced Adversary Emulation and Threat Research team, so ATR. One of the things that we focus quite a bit is studying the different tradecraft of nation state, criminal organization, hacker groups, and we focus on providing our customers a strategic service where we're able to emulate all of these different threats to make sure that they're capable of defending themselves against them. At TrustedSec, we provide multiple technical and advisory services. We provide network penetration testing services, incident response, social engineering, red, purple teaming, hardware security assessment. We even go all the way of providing virtual CSOs, and we also provide employee training. So right now, as I mentioned in the first video, we initially started with where and who and identify controls. So we were going like, hey, we landed the system, they ran our payload. Under what privilege are we running? Under what user are we running under here? What are the controls in the system? And the main reason for this is that knowing this information, if we're running as a regular user, if we're running as network service, if we're running a system, what are the AV products, EDR, firewall, are they logging, not logging, what auditing they have, all of that stuff dictates something very important for us. And just recapping the previous video, and that is what tool set are we going to use and what is our tempo? How fast can we move? And we're going to start seeing that a bit more here. So today, what I'm going to be covering is mostly profiling the system, persistence, and a bit of pilfering. How do we gather data from the system itself? So by profiling, what I'm going to focus is what is the role of this box? What is the intended purpose of it? What is it actually doing? And then we're going to go and who uses this system? Remember, I'm a big proponent of the strategic, not so much of the tactical. So by strategic is where does this person fit inside of the organization? And then we're going to move to persistence, and we're going to look into going like, hey, these are the patterns of life for this system, for this user. Let's see what we can actually do on the system. And then we're going to move into persistence. And this one I'm going to touch briefly because there are just so many persistence techniques, and most of the ones that are I can cover, most AVs are actually looking at those. So more than likely, what I'm going to be doing is recommending for you guys to do a bit of homework there in terms of analyzing several of the tweets and information that comes out there from people like Odavar Mo, Florian, also known as CyberOps, SubT, Matt Graver, and some other researchers out there that as they're kind of showing low bins and com object hijacking and some other techniques, you guys are going to kind of pick and choose persistence techniques that you guys may use. And then we're going to go into pilfering, and that is mostly how do we use what is built into the system to find information in it, so we can exfilter that data out of the system. So let's continue here. So profiling the system. Now we know how fast can we move. We know what are the controls in the system that can get us caught. Now we got to figure out, hey, who actually uses the system? What applications are installed and in use on the system? That's important because that will actually give me an idea on where I can persist, what I can use for persistence, and also it will let me know. For example, if all of a sudden I see Visual Studio, I see NetBeans for Java development, I see multiple SDKs, that to me is like golden. All of a sudden I'm going like, this box that I just landed is a developer box. That means that restrictions on it are going to be quite lax. Application whitelisting should not be enabled here. More than likely, if I run code or I compile my own code, it will go unnoticed, because when you talk with most organizations that actually do EDR deployments, and all of a sudden they're caching MS build, they're triggering on csc.exe and all of that stuff. If I land on one of these boxes, I'm going, more than likely when they deploy the EDR, they're going to have to disable all of those signatures because the amount of false positives that they're getting is going to be quite high. In addition to that, I'm going to find as much information as I can about the user. Where does this user or system, because it could be a server, fits inside the target organization? And as I mentioned, some of the information that we gather on the controls is going to play a key role here. So when we profile the system, first thing we check is this a host, a server, or a workstation? That will depend where do I move next. If it is a workstation, I already know the applications from looking at the controls. And if it is a workstation, quickly I'm going to be going after my documents folder. I'm going to try to find information about the user and AD. I'm going to move that way. And now if it is a server, then I'm going to start going like, who actually uses this server by connecting to it? So instead of me checking, let's say the users folder, I'm going to be checking via WMI logon sessions. I'm going to be looking at the netstat table. I'm going to be looking, does it offer any shares or not to this to the network? I'm going to be checking the disks because I want to know if this server is connected to a SAN or not, or does it have access to a NAS? So I'm going to be looking for another set of information, but very similar if it is a user in a workstation. And then I'm going to move into looking at relationships. I'm going to look like, hey, what is this user actually connecting to, what they're using? Or if it is in the case of a server, what am I going to find in the DNS cache, netstat table, and some other information that's going to tell me how it relates to other systems inside of the network? So in the case of when we're profiling the system, we want to look at the OS type. And one of the things to keep in mind is that I've been noticing this as a trend now more and more and more is that actually developers actually use servers as their desktop. Um, I've actually been in organizations where you go to the um, developer laptop and they're actually running Windows Server on it. Their laptop workstation for all of their development works actually running server with Visual Studio, Office, and all of the tools. And to a great extent, I find that awesome. That means no device guard. That means that more than likely, if the GPOs are using WMI filters, they won't get some of the protections that the regular desktops are because more than likely people are not looking at it. In the case of Mac OS, I have to be honest, I've only seen it once in almost 20 years that I've done infosec, and the only place I've seen it was in a college, in a university, where a professor was actually decided that she wanted to use Mac OS Server, and that's what she was using as her web server for her students. Other than that, I've never seen Mac OS as a server in an enterprise network outside of a marketing department actually using it to render videos. And more than likely, most of those organizations are moving now to off-site services where they actually have farms of Mac Minis, kind of crunching all of those numbers nowadays. So if I go here, I'm in Metasploit right now, and if I go to sessions, I list them. I have multiple sessions to a desktop here. I can use the search feature here and just look for applications. Let's say if I want to look for a module, and there's going to be a post module here called post Windows gather enum applications, which is a module that I can actually use to list all of the applications that are in the system. So I can do here use. I can set my session. Let's use number 6 here. And when I run this, it's going to tell me, hey, this machine has Filezilla, LibreOffice, and this is the version, has a bunch of Visual C++ tool. I can see it as a VMware, has VMware tools. So this already gives me an idea, hey, this is just a low-level employee more than likely. It is not a developer. It's not a sysadmin. It's not a DBA. More than likely, it's not a sales guy because I don't see Java. Most sales systems, for some reason, have Java in their machines. I see it doesn't have a third-party AV product. That means that more than likely they're running Windows Defender in this organization. I can also just go here and do gather. I can do check VM. I can check if they're actually running a VM here. If I can type. It says session 6. So it's a VMware virtual machine. I like checking if it is a VM because one of the things that I've noticed nowadays is that organizations are getting smart. So one of the things that they are typically doing is that they're moving their, how can you say, your exposed, not so tech savvy employees over to VDI. I've been seeing this more and more in the banking area. I've been seeing it more and more in the health area. What they're doing is they're moving to VDI, and anything that has to do with opening Word documents, sending email, receiving emails, and many times it is people that have been bitten by a ransomware is where I've noticed this, that they start moving that way. What happens is that they want these users in a very isolated environment. So they go into and they set up VDI systems for them to manage their email, manage documents. Everything goes into a profile that goes into a chair, and then that system simply gets nuked at the end of the day. And when they reconnect at the next time of the day, that system gets spinned by a master image. So kind of checking if I'm running in a VM or not will provide me a bit of information on what type of VM. If all of a sudden I'm seeing QEMU or I'm seeing something else, that should trigger alarm bells in my head because nobody uses that for a VDI infrastructure, and even less for shared infrastructure in a farm. Most people actually use either Hyper-V or VMware. So these applications actually give me a bit of idea. I can actually just go into my notes, and those should be all of those applications should be saved inside of there. I actually have a bit more information here. Oop, yeah, I forgot to clean out my database before the demo. But yeah, the module actually saves all of this stuff as a CSV inside notes that we can then use and parse to use this data. Also, if you're a pen tester, it is good for you to collect this information because it will allow you to then, as you're progressing throughout multiple customers, it will tell you like, hey, these are the applications that most of our customers are using. This is one common denominator that most of them are using. So this means that we should check those applications for vulnerabilities, specifically privilege escalation, and we should check those also for in addition to
Carlos.
Oh, Chris, your mic is not muted.
You can't see. It's just a webinar. This is our guy out of Puerto Rico.
Nathan, your mic's not muted. How can I mute him? Oh, I'll continue. Ignore the guy in the background. So now moving along, we're moving right now to patterns of life. So one of the things that we should check is specifically on the system is when does it power on and power off? So we're looking at the power on, power off cycles. This includes suspend. In fact, let me fix that before I cut the slides for you and send you the PDF for this in the handouts. And we're checking active connections, we're checking cache interactions, and also then we're going to move over to the user. We're going to say, hey, if possible, log on and log off. When has this user logged on and logged off? This requires admin privileges on the box, what applications are used by the user, and then what are his recent documents, what is he opening. This is where, if you're a red teamer, being friends with the forensic team actually pays off. There's nobody that I know that knows how to profile a system better than a forensics guy. They'll tell you all of the different locations for MRUs. They'll help you develop your shim cache parsing code. In fact, I gotta hand it to the blue team. You guys really know how to look into every nook and cranny inside of a system. As that red teamers, we should actually be learning as much as possible as we can from the blue side. It is highly, highly, highly recommended that you guys do that and build out your own toolings for profiling and just leverage their knowledge on that. So once we land on a system, one of the things that I want to determine is the power cycle pattern. Now, why do I want to know this? Because I want to know what are the work hours of this environment versus from where I'm connecting. And also the work hours for the user. Probably the company works 9 to 5, but this user is one of those that likes to at 4:30 just to log off. And I think I have an extra half an hour and I probably won't. Also, it will give me ideas of, hey, are these guys actually updating their machines? I can actually check that pattern across a month, 2 months, and check how often has this system been rebooted for purpose of service back. And that will give me an idea when are they applying updates or how fast are they applying updates to the machine. It will give me also an idea if I should actually persist or not in this box and how should I persist. Then we want to look at suspends and resumes. Now, this is very important because what you're going to find is if you find is that many people, when they go to lunch, and you have shell and you're going like, oh, they're inactive. It's launch hour where they are. Let me do all of my tasks. The machine may just simply close the lid and suspend the box, and it goes in hibernation, and now you cannot do anything. Or the machine may be suspended every time they leave work, and they simply don't shut it down. So having this pattern of life of the system itself is of great importance to us on how are we going to persist and how are we going to do our configure our sessions. So typically the way I like to do it is that I like to use a method that is compatible across multiple vendors, and that is to actually use WMI. So typically what I do is I do a select, I look for the event code, time generated, insertion strings, and then I typically go after the system event log, and I'm looking for event IDs 6009, and I'm also looking for 1074. 60009 means that the system started up. That means that the system was booted up or had a reboot or or probably crash and simply came back up. At the moment it came back up, it's going to generate an event 6009. That means that the actual service for event log actually got started and came back up as part of a reboot. Then I'm going to look for the shutdown or restart event IDs 1074, and that's where insertion strings become are super useful, because what they're actually going to tell me is if this machine, was it a clean shutdown? Was it a restart started for the user? It was a restart started by somebody else. It's going to tell me if it was a dirty boot or not. It's going to tell me quite a bit of information there just by using this in WMI. And a module that I actually wrote for this, let me get it here, and we'll make this public in our GitHub, is called get power cycle times. And let me do an edit inside of Metasploit so we can look at the source code. Control Shift Plus. Can you guys see the code there well? Cool. So what am I looking here in this module is that I'm actually using the extended API for Meterpreter, and I'm actually executing that query that you saw there. I'm looking for the event code, time generated, insertion string from wing32_NT event log. And I'm looking for time written. More or less, what I'm doing is actually just setting this up so I can control how far in time am I going to look for these events. And I'm looking for system, and I'm looking for event code 6009 and event code 1074. If it is a stop event, which is 1074, I'm going to look inside of the insertion strings that get inserted as part of the message. And I'm going to look at what was the reason for this system to shut down. So let me exit this. I can do sessions, set session 6, sorry. Let me just set G session 6. So now all of them will have session 6. I have to retype it. Let me check show options. It's going to look in the last, let me give it 24 hours or 48 hours. Set max search 48. Let me run this. Must initialize before interface marshal. Oh, I hate this error. I gotta talk with one of the Metasploit developers. Their WMI code tends to crap out on me like that from time to time. Sessions minus I6. Load extended API. WMI query. Select name from Win32 underscore BIOS. And yes, this session is having issues with permissions. In fact, I think the session's actually dead. Hey, demo gods hate me. That's why I have 3 sessions. Session minus I5. That one's also, no, that one's working. Awesome. Background is, sorry about this, guys. Set session 5. Let me run it. Here we go. And now we have the information here where I can see the action. Start, stop, start, stop, start, stop. Then I have 2 stops here, one after the other. Then another start, stop, another start. Here we can see, hey, operating recent upgrade. That means that a patch was installed. Here we can see our reconfiguration. Something was configured in the system, and it was actually restarted. Here we have another one for patching, service pack, plan, installation plan, and this one, no reason was given. So more than likely, this one was user initiated, and this one could have also been user initiated. But at the very least, now I have, hey, it was happening this year, this month, and here I have the rest of the timetable that I can go and just look at it and go like, okay, so I can look at the pattern. I know that they start at 8, they live at 5. I can see a couple of shutdowns here. I can see where they were installing applications. So this will actually give me an idea on how the system's actually managed. If all of a sudden, like it happened to me, and I was checking this on a security company, an actual security vendor, I remember looking at the patterns of life, and when I saw that the Windows laptop had actually not rebooted in 2 months, and the only thing I was seeing were suspends and resumes, I went like, these guys are very, very bad at patching. So yeah, what was happening was that target that clicked on our payload and ran it, what they were doing, just closing the lid at the end of the day, opening the lid back up. When they came back to work, we knew what hours we had to work on, and that they were not applying patches. So that means that any privilege escalation bug or anything that surfaced in the last couple of months, we could actually use those to our advantage. Remember, guys, if you have questions, you can ask those questions at any time, just in case. So if we want to look for the suspend, sleep, and wake and resume events, what we're going to be looking is for startup event ID 1 in the system log, and the source is Microsoft Windows PowerShell troubleshooter. That will actually include the timestamp of when the system actually went to sleep. So here's the WMI query that you can actually use for that. It is select event code, time generated, insertion string, source name, Win32 underscore NT event log, and we're looking for the system where the event code is 1 or 42, and the source name is Microsoft Windows Power Troubleshooter, or source name Microsoft Windows Kernel Power. So we're looking for those. One of the advantages of WMI that I forgot to mention was that you can actually query other systems depending on the level of permissions that you have, and you can actually establish the patterns of life across multiple systems that you can touch via WMI. Or WinRM. You can actually use WinRM to touch other systems. And the more modern versions of server WinRM comes enabled, and sometimes the environments actually enable WinRM on the client machines. So the help desk can actually just do PowerShell remoting and do troubleshooting on the machines. You can actually use that also for lateral movement. And you can establish what is the power cycle and patterns of life of multiple systems, and you can go like, you know what? That system over there is the one that gets rebooted the last. That system over there is the one that I'm going to put my backup persistence in. The rest of the systems, we're going to run them from memory, but that system over there, that's when I want to persist and have my backup because it's the one that's going to be rebooted the last. And my session in memory there is going to last the longest. So let's use that as our backup in case we need to get in. So it allows you to plan more accordingly in the environment. As I mentioned, with Meterpreter, we can actually use the extended API extension, and we can do WMI queries. In the case of Cobalt Strike, we can actually use get WMI object via PowerShell, or we can create a .NET assembly. Now, with Cobalt Strike, you do have to be careful because you're limited to PowerShell and .NET assembly or reflective DLLs. Now, EDR vendors are getting better. Let's say that you hit a box, and that box is actually running, let's say, Symantec endpoint protection, or they're running Endgame. Endgame is an awesome product as an EDR solution. One of the and not only because Devon, the research guy, is super nice, super awesome, and super smart. He has actually assembled quite a good team over there. It is they actually detect when you try to load the .NET assembly. They'll detect reflective DLL techniques, and it will trigger. So, and it will say, "Hey, somebody's doing something nefarious here." But let's say you hit a vendor, and that vendor actually is not that good at PowerShell, and that vendor doesn't subscribe to MC, or that vendor doesn't look for .NET assembly. That means I can actually use .NET assembly to look for it. Now, in those that do trigger on .NET assembly reflective DLL, you can actually use WinRM CMD, and you can do some WMI queries with it. And some of those vendors, I'm not going to say who, actually do not see that. And you can actually do your query and get your data. But do keep that in mind, do test, do validate. There's nothing worse than you spending 3, 4, 5 days to get into a network. You get into the network, and just because you wanted to move fast, didn't test your payload, and you get caught. That will really bum out anybody and will really mess up an entire week of work. So going back into strategic to tactical now, when you're doing a red team engagement, we're looking for what is going to be that business impact to the customer. We want to show them that we can actually impact confidentiality and integrity of their business processes and their systems. So, and this is a big difference sometimes from pen testing. When we're doing red team engagements, many times what is going to happen is that we're not going to go after DA immediately, because more than likely we don't need DA to do or have an impact to the entire business. As I mentioned in the previous webcast, one of the stories was that the person landed in the CEO's assistant's machine. So she had access to all of the CEO's email. She had access to all of the CEO's documents, including his calendar. So I already have the jewels of the kingdom there. I can do whatever I want. So why waste time just going after DA and getting captured if I already have the access to the information I need to check that to show that I can actually have an impact on the confidentiality and the integrity of the business process. And many of you goes like, hey, Carlos, why integrity? Because I can actually falsificate emails, I can modify data, and that data may have an impact to the business. And if it is a DoD contractor, that may have impact of national scale. If it is a government, it may have impact to negotiations for somebody. We're in red teaming, we try to be strategic. How can this be actually leveraged by the threat actors that would go against this specific target or customer that I'm working for? So we want to always keep in mind the strategic side of what we're doing. So things that we need to learn is where the user or users fit in the organization itself, what information and systems they may have access to. And also we want to look what would be the overall impact we may have by having access to this user and the systems. Many times it is we find the user and it is as simple as going into AD and asking AD, give me all of the information of the user. And that information will actually let me know who this person is inside of the organization, because they'll have a description, they'll have their manager. Sometimes you'll see in the comments passwords. Funny story, I remember going into one, and this lady, I think she had been married 3 times, and IT actually placed in the description every time she changed her last name, they would put that in the description. She was previously known by this. She was previously known by this other name. And then there was a note at the end, last name of last husband used as part of password. I'm like, oh, awesome. You just gave me a clue. So every time they reset her password, they use their previous last name for this lady. It seems that they actually had to reset her password quite often also. And that kind of information became very useful to us as we were working on the system. One of the things that many times we want to know is who's actually logged on to the system. And we can get this quite easy just by looking at the processes themselves. So if let me go over here. And if let's go, let me go here, exit here, go here, and I go sessions minus I5, and I go ahead and do a PS. I can actually just look at the user here and saying, it's telling me that the user is from Acme Labs, K Appleton. I have an idea of who this user is. Also, I can actually just use WMI, and I can just do a query here for WMI. Here we go. And I'm going to just select on antecedent from Win32 logged on user. You can actually run this query as a regular user. And what I'm actually looking for is if there's somebody else logged into the system. And so far, only K Appleton's logged into the system. In fact, one of the things that you can actually set is that you can set a background module inside of Metasploit, or if you're running any other tool, you may check on a constant basis for this, and this will actually tell you if the blue team's actually onto you. Have they logged on? Have they used another tool? You may find Nessus scanning the system, and you may get an idea of when that user is actually hitting that system. Because if I go, let's say, into her machine here, let me open PowerShell. I'm running this as a regular user. Let me bring the font up here so you guys can see it. Cool. Let me just copy paste this. This will give me logon user, and then we'll look for logon sessions. Get WMI query. We paste it in. This will give me the information that we were seeing. Tell me logon ID, and it will give me the name. So I'm getting an additional piece of information here, which is the dependent. What is that logon ID? And I can just simply be in my WMI code. Go here for win32 underscore logon session or sessions. I have it in my slides. Go here. I know I don't have it in my slides. Get sim class win32 underscore load order local time logged on user log on session. There we go. There. So get sim instance class. No, get sim instance. Last name win32 log on session, and this log on ID, I'm able to match it to the user, and this instances will actually have even more information in terms of association. I can even look at that other user and see what applications do they have running under their profile. I can see what services are also running under their profile. I can even check what other DLLs. So I can do quite a bit via WMI on the environment just by checking all of this stuff. And I'm covering WMI in general here. I mentioned WMI because I find it to be very flexible, because not only does it allow me to work with tools like Metasploit, Cobalt Strike, and many other agents, even Empire, I can actually write code to run WMI on those, because and also it allows me to run across the network if WMI is available, either via DCOM RPC or WinRM, and I'm actually able to pull this information from multiple systems inside of the target network, which is super useful. So let's continue here. Let me check. Questions? No questions so far, guys? All good? Very silent group. Normally we have more questions by this time. Awesome. So let's continue. Another command that we can actually use is the query command. I can actually look at the sessions. I can actually look at the users by using this command. I find it super useful. One of the reasons that I like to actually use the query command is that many other tools actually use query W to do similar queries. It's another tool also called query. But I prefer this command line tool because most EDRs actually don't catch it. And when I talk with blue team guys, most of them actually don't even know that this tool actually exists. They're looking for who am I? They're looking for other stuff, but none of them are actually looking for query sessions or query users. So now I know what is the active user. Now I need to get information about that user in AD. And one of the advantage of doing AD queries is that as a regular user, I have access to all of the information, read access to every user in the network, to most of their fields. So I'm able to check who is her boss. I'm able to get anything, her address, her phone number. I can get quite a bit of information that I can later use on this target that I controlling her system right now. In addition to that, if let's say if I was able to only get to this box as a lonely network service, I was able to, let's say they're running SQL on the machine, and I was able to get into the machine itself, and I'm running this network service via SQL. Well, I can still query AD. I can pull all of the information via AD because actually the network service account gets proxied under the computer account for all of its queries to the network. So I'm able to still pull account details and group membership for that user. Um, Power View Get Net User is an awesome tool. I just grab K Appleton and I just do Get Net User K Appleton. I'll get all of the details of the user. If I'm either in Metasploit or in Cobalt Strike, I can actually load Power View and run that on the system to get that information. Now, if I'm going against any AV vendor that actually implements AMSI and is able to look at the PS code, Power View is going to be like this humongous red flag that you're launching on that machine because not almost, is every vendor that I know of that integrates AMSI have rules for Power View. For the plain vanilla Power View that you have um, in the GitHub and you run that, every vendor actually has signatures for it. So it's kind of funny because what I typically do is I just go low tech and I use that one liner that you see there. I do ADSI searcher, object class user, SAM account. I put the account name there, K Appleton, and then I do find one and then give me all of the properties of this user. And that actually works awesome. Most users, for some reason, most AV vendors actually, and EDR vendors just simply ignore that query completely. I haven't had this query actually caught by anybody. So one of the things I can actually demo here is I can just copy this, show it to you guys. Faster if I run it here. And okay, Appleton. And here you can see I got all of the information about K Appleton. And it's kind of funny because when I look at title, she's a veterinary technician. But if I look over here in the description, she's also the HR manager. And this is data I actually grabbed from a customer. And what I'm doing is I simply randomize the names. That's why I have this confusion here. But address is real. Some of the information that you see here is real. How they're organized and all of that stuff is real. So here you can see I actually got quite a bit of information: when the account expires, user principal name, when was this changed? It was changed yesterday. Where is this user located? We can use this with the patterns of life to check when this person is active with their shutdowns, their suspends, their reboots. And that single line actually works wonderfully for me. And most AV vendors actually don't catch that. So when we're profiling the system, many times what we want to look is we want to look at Nestat. We want to look at like, what is this user actually connected to? Then I'm going to look at the DNS cache. DNS cache can give me if they're running against Azure, AWS, Oracle. It will give me all of the different host names that they're actually connecting to. I can look at their browser history. I can get quite a bit of information there. Just remember that if you have automated tools that are generating reports and you did pull browser history, Make sure that you sanitize that. It makes for some very awkward presentations if you do not sanitize that. Just a tip there. Also, you can look at the MRUs. These are the most recently used. You can actually look at MRUs for all of the Office applications, video applications. Almost every app in Windows has an MRU, including the Run box in Windows. If have they map any drives, those are also stored in the MRUs. You can get quite a bit of information of what this user is actually doing just by looking at the different most recently used registry keys there. I can map network shares. I can look at what is he connected to. Also, I can look, am I exposing any shares to the network? Which are those? And there are multiple modules that I can actually use here inside of Metasploit. We have Gather Enum IE. There's one called Forensics Browser History that's able to pull off that data. We can also pull the DNS cache. We can do TCP netstat. We can enum shares. We can enum terminal servers. We can even enum Skype conversations, address list, and all of that stuff. Everything's inside of Skype is safe inside of a SQLite database that we can actually query and pull off that data from the system. Now in Cobalt Strike, we don't have this plethora of post-exploitation modules. You'll have to port some of this into .NET assemblies or reflective DLLs to be able to do this stuff. Or you can pull this information actually using PowerShell or just the command line tools if you want. Now, let's move over to persistence. When we are doing persistence, what we're actually want to do is I want to guarantee my access to this box. And by guaranteeing my access to the box, I'm guaranteeing also access to the network. Now, the number of persistent techniques is a very big one. There are multiple techniques that we can actually use for persistence. My favorite one so far is COM hijacking. That is one that I've been using quite a bit recently, but EDR vendors are getting smart around those. I like adding plugins to other programs, either Office plugins, Outlook plugins. Um, it's kind of a cat and mouse game. As soon as we add something and we tell the customer finds a way to detect that, and then we have to research for others and hope that nobody tweets that to the outside world and it gets shared before we can actually use it. And the TTPs for persistence are getting burned quite fast. So that's why I typically don't cover them much detail specific techniques, just cover them in general. So you do have to test each one of your persistence techniques. We've been in customers where a persistent technique is not detected by one vendor. We move to another section or regional office and we make the mistake of assuming. And when you assume, you make an ass out of you and me, is what assume means to me. So typically, we make the mistake of assuming we think they're running the same type of AV vendor. We run our target, and now that AV vendor at the other side actually picks it up. So we just try to be as careful as possible and always test. Now, the three main factors that we should take into consideration before we persist is the level of access on the host and network. If I'm a regular user, I'm only going to persist as a user if I have to. If I have access to multiple systems, I'm going to grab this system that is not a laptop, that probably is a desktop. I'm gonna grab a system if I can that is a server to persist because I want to leverage its position inside of the network to then be able to maintain my access to the network. Also, we're going to be looking at controls. Desktops tend to have better controls than servers. Some organizations actually let's say I remember one that were all of the salespeople were actually running like three different AVs versus everybody else that was only running one. They just simply didn't trust salespeople, and they put uh, more security products, thinking that that would make a difference on them. So I would stay away from the salespeople's machines. And then we got to look at what type of persistence do we want to do. And that is one in memory. This means that the session is going to remain there. So as you saw, my interpreter session died in my demo. So one of the things I want to make sure is that I have a second session always available to me as I'm performing tasks, because that is going to ensure that if I make a slip up, there's some bad code, some bad module, some bad net assembly or anything, I don't crash my shell. That is one of the reasons that in Cobalt Strike, Rafi, uh, bless his soul, he one of the things he actually does is that everything runs in a separate process. It's never every time you run a .NET assembly, a reflective DLL, anything that somebody else is providing for Beacon to run, it's ran under a separate process just to guarantee the availability of the Beacon service itself, that it won't crash. So typically we go in, we create our backup session. We have our backup session. If the system is one that we know that suspends a lot, typically we won't touch disk. We'll just remain in memory, because as soon as we touch disk, our chances of being detected just get exponentially higher. If we know that we're close to those dates that the system may be rebooted or the system may be patched based on the patterns of life or information that we gather, that's when actually we're going to go, uh, and what we're going to do is persist in the best manner possible. And then we're going to go and look for something in this that we can go and that we have tested that won't get us caught. Typically, when we go in, and this is something I learned from my friends at certain agency, is to look for the health of the host. They actually, we were talking many years ago. We were talking, them and I, about patterns of life and how it comes from the military, that term patterns of life, and you're doing surveillance and you're looking for how your mark actually behaves and everything. And one of them actually comes like, hey, but remember, you also have to be a doctor to that system. Like, what do you mean? It says you got to check if that system's healthy or not, so you know if you should persist on it or not, or if you get the heck out of there and move laterally to another host. And we're like, oh, good point. And one of the things they actually told me is event log. Think like a forensics guy. Check that event log. Check what is happening on that system. Windows has one of the most robust eventing systems that you may find in most operating systems. And typically, what we do is we check for event ID 6009. That means that the user was forcibly logged off and a reboot and shutdown was initiated. Um, Also, that means that an update or a critical service actually failed. For example, let's say that the target box running Train Micro and you try to open LSAS, and Train Micro, to protect the box, or McAfee actually does this also, will crash the box to protect it if it is a domain controller. Like, it will go like scorch earth on you and will crash the box if you try to open the memory space of LSAS. Or if it is, yeah, that is, I would say that would be one of the main ones. And you may see something like this, then followed by an event ID 1009, which is a blue screen of death happen, and it will contain a path. If they actually configure it, it will contain a path to a memory dump or mini dump if configured. And when you look this in the event log, that means like gold for me, because depending on the level of access I have, that means that I may have a memory dump that I can actually pull back and pull credentials out of, or I can pull information out of memory and look at other data and stuff that may have been inadvertently saved inside of that dump This happens a lot with servers. People tend to configure full memory dumps on some of their critical servers for troubleshooting, and sometimes they'll forget to clean out those memory dumps, and I'm able to leverage that. Also, we're looking for event ID 1003. That means that a catastrophic error happened and the system was not able to know what actually happens. It only knows that it had a dirty shutdown and doesn't know why did it had that shutdown in the first place. So if I see a pattern of 1001 and 1003, and I see that it happens daily, I want to get out of there. I want to get off that box. If I see it even every other day, I want to get off that box. That means that whoever's that is a that box is janky. I think it's the term is it's not too stable. It's um, we say here in the island it has a fufu on it, so like a witch doctor threw something at it and it's not reliable. In the case that we're running, let's say against OS 10, this is something that we're seeing more and more in the West Coast. We want to go into the folder library logs diagnostic report, and we want to look for panic and wake up resource deoc files. That means that the machine either the panic ones, that means that they had kernel panics, and they'll have a timestamp in their name. This will let you know if the system is an unstable one, and you may want to see if there's SSH keys or something else in that box, and we may want to move outside of that box itself. If we're seeing wake up resource diagnostics, that means that the system is not returning from sleep in a proper manner. That means that there may be some errors in memory, some errors in something else in that Mac machine, and we should move away from it. In the case of Linux, our syslog needs to be configured, and in many cases, I have to be honest, I have not seen it configured, so I'm not able to use those logs very well efficiently across the multiple flavors of Linux to know how um, what is the health of that host is. But I do have to say, if all of a sudden I'm able to see that this machine is a container and it is using Docker or Chef or whatever to manage, I know that my time to leave on that box is very limited. Also, I have to check what actually Chef or Puppet or any other configuration management software is doing. Example, we were able to get into several boxes via a web app vulnerability in their web server. The way they had configured the code, we got shells on those systems, and we then set up a persistent shell on the web server itself, a web shell, and then it got clobbered. And all of a sudden, we go in panic mode, like, "Oh my God, they found us!" But then we started going like, "Oh, this is funny. I'm looking at the netstat data and I'm not seeing anybody SSH into this box. Weird, because we actually had another shell. So we couldn't see anybody connecting to it, but our web shell was completely blown out. It was completely deleted. And then when we look at the logs inside of the machine, there was a log for Chef. And when we look at the Chef log, it actually said that the web folder was modified and Chef was putting it back into a known state. So it was the configuration management system, the one clobbering our shell on the box. And we went like, oh, cool. And it was kind of funny because nobody in the DevOps organization thought of sharing those logs with the security team. That something changed or they didn't even find it suspicious. And we were able to remain in those hosts, in those containers for quite a while, just intercepting people doing requests to them. Now, let's say we want to persist in memory, and the system is a healthy one, but we know that they tend to suspend and sleep the machine and they don't reboot it. One of the things that I actually like to do is that when I create my payload or I inject my payload into another process inside of memory, I'll set session communication timeout to 0 and session expiration timeout to 0. This will allow me to keep that shell always on. That shell is going to always be connected. no matter what, and that's my backup shell. And I'm going to use that in memory in a system that I know that gets suspended, resumed, and has good access. I'll typically set this up as my backup shell, typically. Went back there. Going. In the case of Cobalt Strike, Cobalt Beacon's pretty resilient in memory. I don't have to fill a lot with it like I do with Meterpreter. So typically what I just do is I just spawn another shell, and I'll set jitter and the intervals to very different values, so they don't beacon at the same time or close to one another. And the pattern in the network simply looks different. I'll send it actually to another C2 server somewhere else under another profile. So the traffic looks also completely different. In terms of persistence methods, almost every tool that I see out there, almost every module, CNA, Empire, almost everybody has the run once keys. Almost everybody has those. Don't use them. If you want to get caught, that is the best way to get caught. Go after one of those and use those for persistence. My recommendation, look for better ones. Test them. And I'm sorry that I'm not sharing many here. The thing is that they're just getting burned that fast. If somebody actually puts one out, they get clobbered. So far, I can say that one of my favorites is just using properly code signed Office extensions. That one has worked awesome for many years. Many vendors don't see those. Another one's WMI persistent events. Those still work, and they work quite well still. My recommendation is that if you're creating a new one, that one will get caught. But if you modify an existing one, for some reason that simply still flies under the radar. I think the only one that I've seen that actually have caught me modifying one, an existing one, is Endgame and Windows ATP. Windows Defender ATP, that is. Scheduled tasks, they're still useful. We have to know that if they actually have auditing for other object access events, it will actually generate a 4698 event will be created. If we modify an existing task, it will generate an event ID 4702. But more than likely, people are not monitoring for existing scheduled tasks being modified. Most of the people that I see are actually looking for new ones being created. Another thing that we can actually do is we can modify services via the command line or the registry. We can create new services that use the server controller Windows API. And this, guys, works super well. We can use WMI to create a new service. We can use C, C++. There are multiple WMI classes that just match to the Winterity underscore service namespace that we can leverage. All of them will actually generate 7045. Typically, I try to, if I need to do this, I want to do it around a date where people actually are doing Windows updates. For some reason, they'll ignore or they'll have a series of allowed events during update periods, and one of these that get allowed under update periods is the 745. They typically ignore those in a 24-hour window. Many big organizations actually ignore that during that time window. So if you're running a very long event and it is approaching patch management time, where they're going to be rebooting machines and they're going to be applying patches, that is a good window of time to actually, if you want to persist and you want to take that risk, it's a very calculated risk. You can actually use Windows Service Creations to do those. For Metasploit, I actually have a module called Service Persist that you guys can actually use. We can also use the Meterpreter Extended API. So we can query details via WMI, and we can query DACL on services So we can find services that we can actually modify, that we can replace the executable if we want to or not. And this becomes very useful because nobody's actually, let me go back a bit. If we find a service that we can modify via the registry or the executable itself, we should take that chance because most people or most organizations do not check or do not have auditing enabled for the registry keys of the service. So if we're able to go to the registry and modify that registry, next time that system boots up and comes up, it's going to run the executable that we repointed it to. And it becomes super useful for us. Same thing if we were able to modify that executable because of bad file permissions, we should take advantage of it because many people are actually just looking for a service being modified or a service being created, but they tend not to set up proper discretionary ACLs on the executable or the registry keys to know if somebody actually, instead of going by the SC command and modifying the service, actually went straight and did it to the components of the service itself. In Cobalt Strike, there's a great collection for persistent scripts. Again, Harley Quinn. He has run once, register keys, scheduled tasks, Windows service creation, double align permanent events, GPL modifications. I invite you to look at those if you're actually using Cobalt Strike. Some of them, do be careful, read the source code. They depend on command line tools and PowerShell tools. So do review that source code. On OS 10, we can actually just use the cron tab file. And same as in Linux. There's a Metasploit post module for Linux that will allow you to do cron tab persistence. There's another one that will let you also use launch agents via launchctl in the case of Mac OS. That is exploit OS 10 local persistence, that you can use those to persist in those operating systems. Now, when we're going to pilfering is when we're looking for information that we can abuse or extract from that system that is of business value. We have to be very careful when we're doing pilfering on target box. If the name of the, we got to check the name of the file and some of the strings before we pull it. We don't want, for example, patient records. We don't want social security numbers. We want to proof only that we have access to those, but we don't want to pull them across the network to our laptop, and now we are the ones liable because we now have control of that data. So we have to be very careful with our ROVs. We have to be very careful how we set up our laptop, what is encryption channel, and document all of that stuff. So do be very, very careful with PII when we're doing all of this stuff. Also check the authorized use policies. We don't want to pull private information or compromising private information of the user and the user's life not related to work. And the best way we can mitigate this across the board is just to make sure that the customer provides you a copy of their authorized use policy. And if it says that they're not supposed to use it for personal stuff and that no personal data should be in those systems, more than often we're covered in terms of liability there. So do be careful when we pilfer systems. My biggest recommendation is I typically, in the case of Mac OS, I use mdfind, the command line tool. This is for Spotlight. It works very, very, very well because everything is indexed, so it's super fast. So I can say MD5, anything that has the word secret in the title or inside of it, inside of documents, or with the word password, and I can look for those. In the case of Linux, I can just use find and locate to look inside of those for that stuff. In the case of Windows, Windows is very nice. Windows, after Vista, Microsoft created what they're called the indexing service. So this keeps an index of all files, emails, Internet Explorer, and Edge history on the box. So anything that users actually browsing and all of their emails, if they're using a MAPI client like Outlook or Windows Mail, and all of the files that the system knows how to parse, it's going to keep an index, a fast index that I can query and pull that information out of it. In the case of Meterpreter actually leverages this API. In the case that we land on a Windows box that is 8.1 or Windows 10, we can actually use in program files, Windows Desktop. There's a tool called Search Windows, search.exe. Program. You're supposed to go there. There we go. So what we have there is inside of program files, Windows Desktop Search. There's an executable called Windows Search.exe that we can actually use to do queries. We can search for the most recent used files. We can search for any of the content of the files. And the thing is that I haven't seen any blue teamer or any automatic rules and Carbon Black and many other vendors actually trigger on this and actually look for misuse of this command line tool. So do leverage that. In the case of Meterpreter, the only thing you have to do is when you're running your search is to set the R option for recursive, and that will automatically search emails, MAPI, IE history, and other files. And then you can just download those. Do be careful with this with the sizes. So if I do here, let me do a PS to make sure the session's live. For some reason, it's in dev version and of Meterpreter is not behaving properly. So let me do a search -R. Let's look for secret on this machine. I did. Oh, -R -F. Let's see if it like this. Here we go, and it found recent employee pay raises and eval score link. It found secret employee pay raises and eval scores 2019. Top secret executive bonuses 2019. Yeah, all of those are important documents that I can probably pull from the HR manager and show business impact in the machine. So yeah, good information. I'm using the APIs. Do remember to check idle time on the user when you're running. And this means that this user has been idle for 29 minutes. So she hasn't been active on her box for 29 minutes. So that's super useful for us because it means that if we do any searches or any pillaging and we are hitting that CPU or that disk, we're not going to more than likely get noticed. One of the things that typically happens a lot is that people start doing searches and sadly the target box, this user sitting in front of it and go like, why is it slow? Why is this target actually giving me all of these problems? Cool. So let's go here. So guys, I hope you liked the webinar. Next webinars are going to be February 20th and on March 6th, both of them at 1 p.m. Eastern time. So let's take questions. Do you guys have any questions so far? Not seeing any questions here in the panel. Cool. If there aren't any questions, guys, I do thank you for your time and hope to see you guys in the next webinar. Thank you.